Our solar system is an incredible and vast expanse consisting of the Sun, 8 planets, numerous moons, asteroids, comets and other celestial objects. It is a captivating realm that has fascinated humanity for centuries. The Sun's immense gravitational pull keeps the entire system together, exerting its influence over the planets and other objects within its domain. The 8 planets that call the solar system home are a diverse group, each with its own unique characteristics and individual rotation. Every planet's rotation plays a crucial role in shaping its climates, weather patterns, and overall dynamics. Most planets in our solar system rotate in a consistent direction, but what would happen if their rotation was suddenly reversed? Without any more delay, let's dive right into a more detailed exploration of each planet and their potential consequences if its rotation were to be reversed. 1. Mercury is the closest planet to the Sun and is the smallest planet in our solar system. It has a unique rotation pattern that sets it apart from other planets. Mercury's rotation is quite slow compared to its orbit around the Sun. It takes approximately 59 Earth days for Mercury to complete one rotation on its axis. This means that a day on Mercury is much longer than its year. Mercury's slow rotation has important implications for its atmosphere. However, it's essential to note that Mercury has a very thin atmosphere, often referred to as an exosphere. The slow rotation of Mercury influences the distribution of gases in its exosphere. As the planet rotates, different regions of the surface are exposed to the Sun's intense heat and radiation. These regions can become heated and release atoms and molecules into the exosphere. If Mercury were to reverse its rotation, it would impact the temperature distribution on these surfaces. Also, the side that was previously facing the Sun during the day would now have to face away from it. This change would result in even colder temperatures during the day, as the Sun's heat would no longer directly reach that side. On the other hand, the side that was previously experiencing cold nights might become warmer during the night, as it would now face the Sun. Overall, the reversal of rotation would lead to significant changes in temperature patterns on Mercury. 2. Venus is an intriguing planet in our solar system. It is often referred to as Earth's sister planet due to its similar size and composition. However, Venus has a harsh and extreme environment that makes it very different from Earth. One significant aspect of Venus is its unique rotation. Unlike most planets in our solar system, Venus rotates on its axis in a retrograde direction, which means it rotates clockwise when viewed from above its north pole. This is opposite to the prograde, or we can also call it counterclockwise, the rotation direction of most planets. Venus's slow and retrograde rotation plays a crucial role in shaping its atmosphere. The planet's dense atmosphere is composed mainly of carbon dioxide, with traces of sulfuric acid clouds. This unique rotation influences the atmospheric circulation patterns and weather phenomena on Venus. It also causes Venus to have a phenomenon known as superrotation in its atmosphere. The atmosphere circulates much faster than the planet's surface, creating hurricane-like winds that blow at incredible speeds. These winds can reach speeds of over 200 miles per hour, 320 kilometers per hour, at high altitudes. Venus already rotates in a retrograde direction, opposite to most other planets. Reversing its rotation would essentially make it rotate like the other planets. Because of its extremely dense and hot atmosphere, consisting mostly of carbon dioxide, if its rotation were reversed, it would likely disrupt its atmospheric circulation and weather patterns. Venus's clouds would likely be affected, potentially leading to changes in cloud formation and distribution. In short, the reversal of rotation could have complex consequences for Venus's atmospheric processes. 3. If the Earth started rotating in the opposite direction, it would have profound effects on our daily lives and the planet's climate. Currently, the Earth rotates from west to east, which causes the Sun to rise in the east and set in the west, giving us our familiar pattern of day and night. If the rotation were reversed, the Sun would rise in the west and set in the east. This reversal of day and night would disrupt the ecosystems and have significant impacts on our weather patterns. For example, prevailing winds and ocean currents, which are influenced by the Earth's rotation, would change direction. This reversal would also lead to different weather patterns in different regions, affecting temperature distribution, wind patterns, and precipitation. According to a computer simulation presented in 2018, some big changes would happen if Earth's rotation were to reverse. Deserts would replace parts of North America, and the Amazon rainforest in South America would turn into arid sand dunes. On the other hand, lush and green landscapes would thrive in areas from Central Africa to the Middle East. In this simulation, freezing winters would trouble Western Europe, and certain bacteria called cyanobacteria would bloom in new places where they didn't before. Additionally, an important ocean current called the Atlantic Meridional Overturning Circulation, AMOC, would weaken and then appear in the northern Pacific Ocean instead of the Atlantic. Normally, as Earth orbits the Sun, it completes one full rotation on its axis every 24 hours. The axis runs from the North Pole to the South Pole, and Earth spins in a prograde direction, or from west to east. This direction appears counterclockwise when viewed from above the North Pole. It's the same rotation direction shared by all the planets in our solar system, except Venus and Uranus, according to NASA. The rotation of the Earth influences ocean currents and atmospheric wind flows. In short, these movements will shape various climate patterns worldwide, bringing rain to jungles or redirecting moisture away from dry areas. 4. Mars, our future home, is a fascinating planet in our solar system, often referred to as the red planet, due to its rusty reddish appearance. It has distinct characteristics, including its rotation, which impacts its atmosphere. Mars similarly rotates on its axis to Earth with a prograde rotation, meaning it spins counterclockwise when viewed from above its North Pole. However, Mars has a longer day than Earth, with one Martian day lasting approximately 24 hours and 37 minutes. The rotation of Mars influences its atmosphere in various ways. While Mars has a thin atmosphere compared to Earth, it still plays a significant role in shaping the planet's climate and weather patterns. The rotation affects the temperature distribution across Mars. Just like Earth, Mars has poles and an equator. As the planet rotates, different parts receive varying amounts of sunlight. The regions near the equator receive more direct sunlight and tend to be warmer, while the polar regions receive less sunlight and are colder. Mars experiences distinct seasons due to its axial tilt, similar to Earth. As the planet orbits the Sun, the tilt causes the Sun's angle and intensity to change, leading to seasonal variations in temperature and weather patterns. The rotation of Mars also influences its atmospheric winds. Reversing its rotation would impact its climate and weather systems. Mars currently has colder temperatures near its poles and warmer temperatures near the equator. If its rotation were reversed, these temperature patterns would likely change. The side that was previously experiencing colder temperatures might become warmer, while the warmer regions might experience cooler. This reversal in the rotation could potentially impact the polar ice caps and alter the dynamics of Martian atmospheric circulation. It would also have consequences for the planet's weather patterns and an increased occurrence of dust storms. 5. Jupiter is the largest planet in our solar system. Often referred to as a gas giant, it has a fascinating rotation pattern that has a profound impact on its atmosphere. Jupiter's rotation is incredibly fast, making it the fastest spinning planet in our solar system. It completes one rotation on its axis in just under 10 hours. This rapid rotation gives Jupiter its distinct flattened shape, causing it to bulge at the equator and flatten at the poles. The fast rotation of Jupiter influences its atmosphere in several ways. One notable feature influenced by Jupiter's rotation is its prominent bands of clouds. These bands, seen as alternating light and dark stripes on the planet's surface, are created by the planet's fast-moving winds. The interaction between different layers of gases and the Coriolis effect, a phenomenon caused by the planet's rotation, leads to the formation of these distinct cloud bands. If Jupiter's rotation were reversed, it would impact its powerful atmospheric storms, including the famous Great Red Spot. These storms are driven by the planet's rotation and its complex atmospheric dynamics. Reversing the rotation would likely lead to changes in the structure and behavior of these storms, altering their sizes, shapes, and lifetimes. In short, Jupiter's intricate cloud patterns, composed of different atmospheric gases, would also be influenced by the reversal, potentially leading to modifications in the planet's formation and distribution. 6. Saturn is another magnificent gas giant in our solar system, known for its iconic rings. Just like Jupiter, Saturn's rotation plays a significant role in shaping its atmosphere. Saturn's rotation is relatively fast, but slightly slower than Jupiter's. It completes one rotation on its axis in about 10.5 hours. This relatively rapid rotation contributes to Saturn's flattened shape and the prominent equatorial bulge. The rotation of Saturn influences its atmosphere in various ways. Saturn's atmosphere is primarily composed of hydrogen and helium, with traces of other gases. The planet's fast rotation creates powerful winds that circulate within its atmosphere. One striking feature influenced by Saturn's rotation is the presence of cloud bands. Similar to Jupiter, Saturn showcases distinct bands of clouds encircling its surface. These bands are caused by the planet's fast-moving winds and the interaction between different atmospheric layers. Reversing its rotation would have consequences for its weather patterns and dynamics. Similar to Jupiter, Saturn's atmospheric storms and cloud formations are influenced by its rapid rotation. Changing the rotation direction would impact these storms and potentially alter their sizes, shapes, and intensities. Saturn's famous hexagonal-shaped jet stream, observed at its north pole, might also undergo modifications due to the reversal in rotation. The intricate dynamics of its iconic ring system, composed of icy particles, could also be influenced, but the exact changes would depend on the complex interactions between the rings and the planet's gravity. 7. Uranus is an intriguing planet in our solar system with a unique set of characteristics. One of the notable aspects of Uranus is its strange rotation and how it impacts its atmosphere. Uranus has a peculiar rotation compared to most other planets. While most planets rotate on their axes in a prograde direction, counterclockwise when viewed from above the North Pole, Uranus has a retrograde rotation. This means that Uranus rotates on its side, with its axis tilted at a significant angle compared to its orbital plane. The extreme tilt of Uranus's rotation axis has profound effects on its atmosphere. As a result of this sideways rotation, Uranus experiences extreme seasonal variations. Each pole of Uranus faces the Sun directly for half of its 84-year-long orbit, leading to long periods of continuous daylight and darkness. The unique rotation of Uranus influences its atmospheric dynamics in several ways. The planet's atmosphere is primarily composed of hydrogen and helium, with traces of methane, which gives it its distinctive blue-green color. Uranus's extreme tilt causes the atmospheric winds to blow predominantly along latitudinal lines, rather than longitudinally as on Earth. This leads to the formation of narrow east-west bands of clouds and storms in Uranus's atmosphere. If its rotation were reversed, its axis would shift to a more traditional orientation. Uranus's extreme axial tilt causes its polar regions to experience long periods of darkness and light. Reversing its rotation would significantly impact its climate and weather systems. The polar regions would undergo more extreme seasonal variations, with extended periods of daylight and darkness. This change would affect the distribution of sunlight and alter the atmospheric circulation, leading to different wind patterns and potentially influencing cloud formation and weather phenomena. 8. Neptune is a captivating planet in our solar system, known for its stunning blue color and dynamic atmosphere. The rotation of Neptune plays a significant role in shaping its atmospheric characteristics. Neptune's rotation is similar to that of Uranus, as it also has a retrograde rotation. This means that Neptune rotates on its side, with its axis tilted at a significant angle compared to its orbital plane. This unique rotation sets Neptune apart from most other planets in our solar system. The sideways rotation of Neptune affects its atmosphere in several ways. The planet's atmosphere is primarily composed of hydrogen, helium, and traces of methane, which gives it its distinct blue appearance. Neptune's rotation influences its atmospheric circulation and weather patterns. The extreme tilt of the planet causes the atmospheric winds to blow predominantly along latitudinal lines rather than longitudinally as on Earth. This leads to the formation of bands of clouds and storms that encircle the planet. Reversing its rotation would likely impact its weather patterns and atmospheric dynamics. Neptune experiences powerful storms and high-speed winds in its atmosphere. If its rotation were reversed, the dynamics of these storms and winds would be affected, potentially altering their intensities, durations, and structures. The intricate cloud formations observed on Neptune, composed of various atmospheric gases and icy particles, might also be influenced by the reversal, leading to their formation, distribution, and coloration changes. 9. Pluto is a small and distant dwarf planet, located in the outer regions of our solar system. Although it is not considered a full-fledged planet, it still exhibits interesting atmospheric characteristics influenced by its rotation. Pluto's rotation is relatively slow compared to the inner planets of our solar system. It takes about 6.4 Earth days for Pluto to complete one rotation on its axis. This slow rotation affects the dynamics of its atmosphere, which is composed mostly of nitrogen, with traces of methane and carbon monoxide. Due to its small size and low gravity, Pluto's atmosphere is very thin and tenuous. It extends only a short distance above the planet's surface. However, despite its thinness, the rotation of Pluto still has an impact. Pluto's rotation influences the atmospheric temperatures across its surface. As different regions of Pluto rotate in and out of sunlight, temperature variations occur. The side of Pluto facing the Sun, known as the day side, receives more sunlight and becomes relatively warmer, while the opposite side, the night side, is colder. These temperature variations can lead to the movement of gases within Pluto's atmosphere. As the day side warms up, some of the surface ices, such as nitrogen and methane, may sublimate, transitioning from solid directly to gas. These gases can then rise and spread out within the thin atmosphere. The rotation of Pluto also affects the distribution of frosts on its surface. If Pluto were to reverse its rotation, the consequences would depend on its specific characteristics. Its thin atmosphere, mainly composed of nitrogen and methane ice, might undergo modifications in its circulation patterns and interactions with the surface. The dynamics of its surface features, including its mountains, plains, and icy deposits, might also be influenced by the change in rotation. However, the exact consequences are not yet fully known due to limited data and our understanding of Pluto. In short, it's important to note that these scenarios are hypothetical, and reversing the rotation of planets is highly unlikely to occur naturally. The rotation of planets is influenced by various factors, including their formation, gravitational interactions, and conservation of angular momentum. However, isn't it interesting to assume? Hope you enjoyed this content. Thanks for joining us on this thrilling adventure. Don't forget to like this video, subscribe to our channel for more space-related content, and hit that notification bell to never miss an update. Until next time, keep looking up and keep exploring the wonders of the universe.